Example 12. Amongst NiCO4, NiCN4 2- and NiCl4 2-, the option A is saying NiCO4 and Cl4 are diamagnetic, NiCN4 2- is paramagnetic. Option B says NiCl4 2- and CN4 are diamagnetic, NiCO4 is paramagnetic. So basically you need to find out about their magnetic property. We know that a substance is paramagnetic if it contains unpaired electron. It is diamagnetic if it does not contain unpaired electron. To understand whether unpaired electrons are present or not, we need to apply VBT, valence bond theory. In NiCO4, first let's consider NiCO4. Nickel here is in zero oxidation state. Therefore, it has 28 electrons. If I am taking argon, which accounts for 18 electrons, then there are 3D, 10 electrons remaining. If 3D has 10 electrons, meaning it is full, that time the hybridization which will occur is sp3, because S and P, 4s 1 orbital and 4p 3 orbitals are involved in the hybridization, giving sp3 hybridization. The 3D subshell here is completely full. The sp3 hybrid orbitals also will be completely full. There are no unpaired electrons in this case. Therefore, NiCO4 is diamagnetic. Let's consider the next complex here, NiCN4 2-. Nickel here is in +2 oxidation state. So, out of 28 electrons, 2 electrons are lost. So, we have 26 electrons. Considering argon, 18 electrons, 3D, 8 electrons are present. This means that if there is ligand which is strong, like cyanide ligand, the electrons are pushed against Hund's rule. So, the electrons initially were like this, that is 5 electron. This electron pairs up here, the 8 electrons are arranged in this manner, freeing up S and freeing up D, S and 2p orbitals, thus giving us dsp2 hybridization. If we put electrons from the ligands, we see that there are no unpaired electrons, and hence once again this substance also is diamagnetic. Considering the last example, NiCl4 2-. Once again nickel is in 2+ oxidation state, and therefore there are 8 electrons in 3D. This time chloride with ligand is a weak ligand, and therefore the electrons are not pushed against Hund's rule. So they occupy the orbital 3D in such a fashion. There are 2 unpaired electrons remaining here. sp3 hybridization therefore occurs here, and this substance nickel, which is attached to Cl4, this substance therefore has 2 unpaired electrons and is paramagnetic. Considering now this question, so this is wrong here because NiCl4 is not diamagnetic, it's paramagnetic. Once again this is also wrong. So here we can see that option C is correct. NiCO4 and CN4 are diamagnetic. NiCl4 is paramagnetic. Let's also remember their hybridization. NiCO4 undergoes sp3 hybridization. NiCN4 undergoes dsp2 hybridization. NiCl4 undergoes once again sp3, but this time paramagnetic, leaving 2 unpaired electrons. Option C is our answer.